Okay, so in today's lesson, in lesson 3, writing functions, we're going to start off by talking about there's kind of like some terminology that we need to talk about. And first of all, I want you to cross out the S in expression there because that's not written well. An algebraic expression that defines a function. Does anybody know what that's called? What's that called? When you have an algebraic expression that defines a function. In other words, it tells you what's going on in it. A function rule. It is called a function rule. So when we can set up an algebraic expression that tells us how that function operates, basically, we call it a function rule. Well, every function has an input and an output. Okay? The input of a function is what we call the independent variable. So we decide what we're going to put into the function. So that situation is considered, we're going to let that be represented by the independent variable, and it is used in the function is used in the function rule. So whatever we decide that independent variable is going to be representing, that's going to be in the function rule part of our equation. And typically we use x for the independent variable. If we're using x and y, for sure we use x. If we're using a different variable, like a and b, then we have to state, okay, a is the independent variable, b is the dependent, or whatever we choose to be. But typically, especially if we're going to graph it, the independent variable is x. And the output of a function is the dependent variable. Yes, the dependent variable. What you put in for the independent variable, you have an output, and that output is dependent upon that independent variable. And typically, that is y, and the function rule is set equal to that. So the function rule is on one side of the equation, the dependent variable is on the other side of the equation. What happens in the function rule spits out an output. It produces something that becomes our dependent variable, our y value. But sometimes they like to use a different type of way of writing functions, and that's commonly used, and it's called function notation. When you see function notation, you're like, okay, I know this represents a function. We cannot use function notation if it's not a function. So the function rule is set equal to, instead of y, the dependent variable, the function rule is set equal to f parentheses x. So we won't see a y there, we'll see an x again. But basically what that is saying, here's how we read that. F of x, where f names the function. What it's saying is this is a function, and the independent variable is x. So what you get for me, f of x, is dependent upon what you put in the function rule for the independent variable x. So keep this in mind. When you see this, you can always think that, okay? They're interchangeable. F of x and y are interchangeable. They both represent, in the end, the output, the dependent variable, okay? So, writing an equation for a function, you've got to decide what function rule is. So we have a table here where we have some ordered pairs, and when x is 1, y is 4, when x is 2, y is 5, and so on. We have to decide what's the rule that's going on here. What happens to x that in the end results in y?
3 is being.
Okay, so 3 is being added to the x value. So if we add 3 to each of the x values, does it spit out the y value? So in other words, is 1 plus 3, 4. Okay? 2 plus 3, 5. 3 plus 3, 6. And 4 plus 3, 7. It's got to work throughout the whole table. You can't just do it at the very first one and say it works and then forget about the rest of the table. To make sure that function rule would complete the whole table. So if you, let's put that down in words. If you add 3 to x, you get y. If you add 3 to x, you get y. So we're writing the function rule, basically, or the function in words. Well, then what would the equation look like?
X plus 3 equals y.
Yeah, x plus 3, or 3 plus x, doesn't matter, addition's not fussy. X plus 3 equals y. There's our equation for that table, for that function. Okay, is it a function, first of all? Can we be sure that it is a function? Look at that table. Is it a function? Okay, why?
Each x value is only one y.
Yeah, each x value in that table only has one y value, doesn't it? So it is a function, so then we can write this in function notation. So in place of the y, we're going to put f of x. So x plus 3 equals f of x. Remember, y and f of x really are interchangeable. They mean the same thing as long as it is a function. We might also see that typically we would see it written with the y first in these equations. Typically it would be written starting with the dependent variable equal to the function rule. Typically that's how you will see it written. Okay? So that reads f of x equals x plus 3. This is a function, and whatever you put in for x into the other side, you'll get your output. You'll get what it's equal to at that time. Okay. Any questions on that one? How about number 2? Think you can figure out what's going on in that one? Sometimes it's easier, and I might recommend that you do this, sometimes it's actually easier to put it into a table like we had our last one, and then it's sometimes easier to be able to see the relationship between the x and the y. Braden?
It's just like 1 plus 1 plus just kind of shows up like the 1 1 is 0, then 2 3 is plus 1, 3 5 is plus 2, 4 7 is plus 2.
Okay, so we're saying that if we add 1 more each time, how would we, okay, so if we say that, if we add 1 more each time, how would the function rule look then? How would that look algebraically? Could we say x plus 1 equals y? Let's see, can we? So x plus 1 equals y. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4, not 5. So that function rule wouldn't work. We got to figure out how can we get it to work then. Jacob?
X plus 1 is equal to y plus 2.
We want y by itself. We don't. So if you can get that so that y is all alone, maybe that will work. We don't want anything happening on the side with y. Y is the output. It's what's going to happen from the function rule. So can we come up with a function rule? And by the way, you don't have to just add or subtract. Sometimes you might have to multiply or divide. Sometimes you might have to do more than one thing. Oh, I have the wrong value in here. I'm sorry. This is wrong. Nobody caught me on that?
I did, guys.
Yeah, you need to tell me. Sorry, because that changes things, doesn't it? Yeah, because the first one's 1, you don't add anything to it like Braden, that's what you were. I was kind of misunderstanding that from you. 2 plus 1 is 3, okay, and then, so 0, it goes up 0, 1, 2, 3, okay. Jared, what do you think?
1 equals x times 2 minus 1.
X times 2 minus 1, so if we're going to put it in words, we would say double the x value and subtract 1. Does it work all the time? Okay, so double 1, what do you get? 2, and 2 take away 1 is 1. Double 2, what do you get? Take away 1, 3. double 3, take away 1. Double 4, 8, take away 1. I think Jared found the function rule. Okay, so if you multiply the x by 2 and subtract 1, you'll get y. We worked all the way through our table. Whatever rule we come up with, it has to work all the way through. So then, as Jared said, the equation would be double x, take away 1, you will get y. 2x minus 1 equals y. Okay. Is our set of ordered pairs a function? Okay, so if it's a function, we can write it in function notation. So what does function notation look like for this one? 2x take away 1 equals f of x. Y just gets replaced with f of x. It's still representing the output, f of x is, but it's telling us that this is a function and x is the independent variable. So you get to put stuff in for x and see what you'll get out for y. Okay, so that's just practicing that. There should be more of that in your book also. So any questions or concerns about that at the moment? Okay, then let's go to the back side. And if we're given a situation in words, we have to decide what's the controlling variable, what's the thing that kind of controls the situation, and then what's the result of that. So remember, the independent variable, the x, controls the situation, and then whatever happens with x gives us our y. So we want to decide in any situation what's the thing that's going to control the other, and that will be our independent. So a doctor needs to know your weight before determining the amount of medication. So what's the independent variable in that situation?
Weight.
Your weight. Your weight is going to, so weight would be represented by our x, and the dependent, once the doctor knows your weight, what's dependent upon that? Sure. Amount of what?
Medication.
Well, we gotta probably be a little bit more, amount of medication. So the amount of medication the doctor's gonna give you depends upon how much you weigh. A child's not gonna get as much medicine as I'm gonna get for the same thing because I weigh more than that child does. So a doctor doesn't just say, okay, well you have a cold, so everybody gets the same amount of this type of medicine. And that is actually how it works. Okay, a company charges $10 per hour to rent a jackhammer. What controls this situation? What would be the independent variable? What did you say first, Jim? You said $10? Okay. And what did you say, Courtney? How much it costs? How many hours?
I think it would be the amount of hours.
Does the $10 change?
No.
No. So that's kind of like a constant that doesn't change. So that isn't going to control it necessarily. It's part of it. But remember when that function in the front, when we doubled the x and then subtracted 1 to get the y? That's kind of like saying here, oh, well, maybe you have to multiply by 10 or something. So I think the 10 is, that's not negotiable. But what is negotiable is how many hours you rent the jackhammer for and how much money it's going to cost you altogether, right? So which one's dependent upon the other? Which one controls it? The hours does, doesn't it? How long are you going to rent it? If you only rent it for an hour, then it's only $10, right? But if you rent it for 4 hours, then it's $40. So the number of hours you rent it is the control, the independent variable. What's the dependent then?
Total cost.
Total cost. And you can't just say cost. You're going to say total cost because after you know how many hours you rent the jackhammer for, that gives you the total cost, which there's only one time it's gonna be 10, and that is when you only rent it for an hour. Okay, any questions? Okay, now, let's write equations. And when we write equations, we always have to first pick the independent and the dependent variable like we just practiced here. So identify the independent and dependent variables, write an equation in function notation for each situation. So a math tutor charges $35 per hour. What do you think is the independent in this one?
Hours.
Number of hours, yeah. Again, how long you want to work with that math tutor is going to determine the dependent, and what's the dependent? Total cost again. Okay. So basically, we can now say that X would be that, right? Hour. Okay, what do you think the equation would be then?
X times 35.
So 35X, could I write it like that? Does that mean 35 times X? Yeah. 35X equals Y, but remember, okay, so we'll start it out that way, but remember they want it in function notation. So we're going to replace that Y with f of X. So let's do f of X equals 35X. So if you have the math tutor for 1 hour, it's going to cost $35. In other words, f of 1 hour would be 35 times 1, $35. What if it's for 3 hours? F of 3, 35 times 3, 105. $105. Okay, let's look at number 4. Fitness center charges a $100 membership fee plus $40 per month. What's the independent?
Months.
Number of months, yeah. It determines, how much extra money you're going to pay is determined on how many months you're going to be there. How about dependent then? Total cost. Oftentimes it turns out in life that how much we're going to spend is dependent upon lots of different things, right? Okay, equation.
100 plus 40x equals y.
The $100 that's non-negotiable, doesn't matter whether you go or not, just to join they're going to charge you that. They're going to charge you $40 every month, so 40 times x equals y, but remember we're putting it in function notation, right? When you're doing these in your homework, I want you to take some time, I want you to write down what's the independent variable, what's the dependent variable, what's it representing. Not going to put down independent variable x and dependent variable y. That's a given. But from that situation, what in that situation is the independent variable representing, and what is the dependent variable representing, and then write your equation, and then pay really close attention if they're asking it for you in function notation. If they're not asking it in function notation, you can just use y if you want. Okay? Now I have a question for you. Does f of x represent domain or range? What do you think, Jared?
Range.
You think it's the range.
F of x is the y value.
Because f of x is the y value, and remember the range is made up of y's, isn't it? So it represents the range. Okay. So what makes up the domain then?
X value.
The x value. So the independent variable would make up the range, or the domain, and the domain comes from what's going to go into the function rule. What values are you going to put in for x? Okay, there are some other things that you will be coming across in your homework that should be in your SQ3R, or when you can can use your notes, or your book I need to help you with. There is another page of these notes that you don't have yet that we'll finish on Monday.